All right, looks like it's about time for us to start. I don't see Brendan on the meeting yet.
That's not good. All right, so let me see if I can share the chair slides, and Dave Waltermeyer, you want to do the intros when I get them up?
Happy to. All right, everyone. Welcome to the SUIT Working Group meeting at IETF 110. My name is Dave Waltermeyer. I'm joined with my co-chairs Russ and Russ Housley, Dave Thaler. As you can see, there's the note well. You've probably seen this a few times so far this week. As always, let us know if you have any questions about its contents. You also agreed to it when you signed up for this meeting. If you could advance to the administrative tasks, Russ.
Oops, I grabbed the wrong slide when I went full screen, didn't I? Sorry.
No worries.
So many slides. I should have put them all in one file, but I didn't. I go here, I go here, and then I say full screen.
Ah, much better. Let's see. So, so Dave, we have two note takers. Or we're still looking for one?
Yeah. I think it would still be useful to have a second one. So I am taking some notes, and I would love to have somebody assist me.
Can we get a volunteer to be a note taker? Maybe you can respond in chat. We'll wait.
If I remember right, either last IETF or the one before, Akira helped out as one of our note takers. It's good to spread the wealth, but otherwise I'm wondering if Akira could help me if nobody else steps up.
We'll begin as soon as we have a note taker.
Okay, Akira says, okay, sure. I know Akira's done it once, but so it'd be great to have a different volunteer, but I appreciate, thanks Akira. So I guess we can go on, and I will try to keep the English well if you can make sure that I don't miss anything. So, okay, thank you, Jessica. Great, so we got Jessica as well. Great, so the three of us will do it.
Great, thank you very much. Okay, and you can follow along on the CodeMD where we'll be actively taking notes. So if you have anything to add to the notes or correct, feel free to do so. Next slide, please. So today we have a pretty full agenda. We're going to be covering status on a number of drafts. We also have an update on the secure reporting, which has been asked. We have a call for adoption, currently underway. We'll also talk about some new work, and if we have time, we'll have open mic for any other business. Any agenda bashing? All right, next slide, please.
I think there might actually be one minor bash. It's just a point of order here, which is that the question of recharter seems to be in section 6, but it strikes me that it probably belongs before we talk about secure reporting.
Okay, and what's your thoughts there? Yeah,
I thought we concluded last meeting that the suit reports does not require a recharter, only the MUD does, and that's why the agenda slide is put that way.
That's correct.
Thank you.
And that's because the suit reports were previously in the suit manifest, and we can decide whether to split that into a separate document or combine them or whatever. And I think that's what Roman, I think you commented that at the end of the suit agenda at 109. So.
Yeah, and speaking as the AD, yeah, that's totally fine, like we talked last time.
Excellent. So we'll cover the recharter topic then in the last item. In general, we've done fairly well with our milestones, although we're behind on getting the the manifest format sent to the IESG by about a year right now. We're pretty close. So I would like to make sure that we're talking about during that segment of the meeting, what last bits of work needs to be done to get it across the finish line. Next slide, please.
That's the last one.
Okay. So I think up next we have Brendan or Hannes with the architecture and information model.
I think this is Brendan is going to talk about the.
I think we're going to.
No, we're skipping the architecture because it's in the editor queue. There's nothing to talk about. So Brendan with the information model.
Right. I just wanted to make sure we said that for the minutes.
Oh, yeah.
I was
Okay.
confused. I was looking at the architecture going, I don't have slides for this.
It'd be nice to have the architecture published. All right. Go ahead, Brendan.
All right, so the information model has been through IESG review now, and there's a few items of feedback. There were a number of relatively minor nits, but I've brought up 3 points that seem like they require a little bit more discussion. So the first one was, why are we constraining device identity matching to UUIDs? And I have a few reasons that I made this recommendation in the first place, and indeed that we discussed previously, I think. So the first point here is that text tends to end up getting parsed. It rarely stays as string matching. So one reason for using UUIDs is to encourage people to do the right thing, to use these for matching an identity rather than matching a complex sequence of characters. The second reason is that they're guaranteed to be 16 bytes long, which means that devices have a simpler time doing matching. There is no question of variable length or what happens if I only match the first part but not the second part of a string. If it's 16 bytes long always, then this is guaranteed. And then finally, the 2 other points on this are that the text section is what's there for human readable things. So if you need something human readable, it should be in the text section. But devices don't really need human readable things, so we should give them things that are easy for devices to process. And the vendor and class ID are really for testing applicability, not for asserting properties. And I think that's an important point that gets lost a bit in this in this format, that the manifest does not assert properties, it tests things. And those are different concepts. So that's essentially my feedback for the UUIDs. I guess the question here to the group is, do we need to document this more clearly? I guess I'll just continue on here and we'll do some discussion at the end. Does that make sense?
That's fine.
I guess we can do it either way. I guess my only comment on the UID's point is we had a similar but different, constraint discussion in the context of, I think it was rats, and there the discussion was rats and TEEP basically, because there it's a little bit different because in the other context, you're trying to potentially, you have a reason to say, take an identifier, whether it's UID or whatever, and look up some other information, not on the device, but on the management side, like if you're going to look at an index or something. But here, if it's embedded in a SUIT manifest, and you have all the rest of the SUIT manifest, including any human readable strings in the text section as well. And so I think the reasons that other groups needed to go with something beyond a UID and have delegation, my belief is those reasons don't apply to SUIT. But since that is a common discussion on the working groups, it might be useful to say what you just said and to distinguish it so that, because it seems like it's going to be a frequently asked question. And if it's a frequently asked question, it's useful to have a frequently answered one.
Fair enough. Okay. Then the next item was that the delegation mechanism was too vague. So this is delegation specifically in the context of delegating from one signatory to the next. So from a root of trust through multiple delegate firmware signers. This was deliberately left vague to leave space for detail in the in a given manifest serialization. The idea in the information model was that delegation should be a thing that can be done, and the broad strokes of how it should be accomplished are laid out there, but not the specifics, because that seemed more appropriate for a serialization. Does the working group feel that we should move more of the definition of the exact process of delegation out of the manifest serialization and into the information model? Okay, and I guess in the interests of time, we'll let people ponder that and move on to the next one then. So next slide, please. Right. There's a requirement on secure time, specifically for the expiration of manifests. There isn't any reference in that description on including a reference time source. The only thing that's defined is that this so-called secure clock needs to be monotonically increasing, among other things. But that's the key requirement, and it doesn't mention a reference time source. So the question is whether we should define a reference time source as being part of having a secure clock or not. I think that it probably makes sense. I guess the only argument I can see against adding that text is that you could quite easily have a secure relative clock as long as you express your expiration times in relative terms. However, the manifest as it stands today uses absolute time for expiration times, so that's probably not the right answer. So I think on that basis, we probably should make a reference to having a reference time source.
I just jumped in the queue. Speaking as individual contributor. I mean, generally, secure time, though, is more than just providing a time source. It's about verifying that the time came from that source, using a signature.
Yeah, sorry, I should have said a secure reference time source.
Okay.
Okay, well, that's it for the information model. So barring any additional commentary, I think we can move on. Hannes, I guess, is here.
I only wanted to point out that in addition to those three, which I think are the meat or the sort of the core questions that haven't been addressed with the latest draft update, there are also a few others which we need to go through, and it didn't work out to do those in time for the deadline. So I'm going to do the update next week on those, or this weekend. So it's only sort of nits and things that need to be changed here and there. Yeah. But it's coming to an end, I would say, with the changes that or proposed changes that we just discussed.
Regarding delegation, I think we need a little more detail, but not everything that's in manifest. And so I'm hoping we can come up with enough that makes it clear what's going on, but at the same time, I don't think we want to dilute what's in the manifest to the point that it makes it hard for an implementer to find the text.
Russ, I almost hear you suggesting that we should add an example in a manifest document.
Well, I didn't go that far, but that's not a bad idea. But I think that creates some work for Brendan.
Well, and you have to balance the question of whether it makes sense to add more examples to this document. It has six.
Exactly.
It's huge.
It is huge.
Yeah. I mean, I wouldn't be against having a examples document that's separate. I don't think there's anything wrong with that. And the other aspect of that is that we can add to it over time if that's what is helpful.
Yes, that approach was taken for S-MIME. And so there was both good and bad examples there so that you could say, this is expected to fail, this is expected to succeed. We could do that if there's somebody willing to put the time into it.
Okay. Well, I mean, that is probably a question that we should discuss when we get to the manifest, which I think is now. I could be wrong.
Roman, go ahead.
Just wanted to pull on the thread about the examples. I know there's sometimes cultures in working groups or rumors that the IESG doesn't support these add-on documents, these add-on informational documents relative to protocol spec. I personally find them really helpful for implementers, especially if you're co-developing it with the spec or after the spec is made, just to be very practical to show those. So from a personal perspective, I think we should do it. As an AD, I'll happily support such a document.
Okay, so there's a new version of the SUIT manifest up. There are very few changes. So there were a couple of example changes, and it's just that there were errors in the encoding. And this had to do with the CDDL getting out of sync from the example generator. So that has been fixed now. And in terms of editorial changes, that's it. There was one feature addition, which is on the next slide, and that is a specific request from TEEP. TEEP requested the ability to delete a component. Now, the problem with deleting a component as an imperative is that it can end up causing a lot of dependency problems. If you're able to delete a specific component and that's depended on by an out-of-tree manifest, or indeed a daemon dependency, then you can end up with a broken system fairly easily. There's also questions about who actually has the authority to delete trusted components. And then there are, two different TAs, yes. So the other question is what happens when it's already been deleted? And in terms of the atomic nature of manifests or of updates, there's the question of what happens if you use a component partway through an update, then delete it, and then something fails afterwards. You no longer have the component that you need to be able to use it in the first part of your manifest when you have to try again, and so you can end up breaking the entire manifest, even though it's supposed to be atomic. So I think that either an unlink or a garbage collect type idiom would make more sense to me. Next slide, please. So the idea here is that you mark a component as unused by the current manifest tree. You might also include something like decrementing a reference count on that component. And the idea here is that if it's marked and its reference count is 0, then at the end of the current section, or indeed here where section is used, it may mean the whole process of doing either a secure invocation or an update, and that's, I think, probably the most likely approach. When that's done, then the manifest processor will check all of the marked components, and any that have a reference count of 0 can safely be removed, since they've already been used to the degree that they are likely to, and there shouldn't be any dangling atomicity problems. So I would support the addition of a garbage collect or an unlink directive, and I've put one of those into version 12. I'd be very interested in the working group's feedback on that approach to explicitly removing a component. This gives the manifest processor a bit more say over when and how that happens, which I think is probably important, especially when there are multiple non-interdependent root components. So after this slide, my content's done, and we'll hand over to Hannes. So if there are any questions or comments on this, I think this would be a good time to break for them.
Sure. So I think I jumped in queue. So I think from the TEEP requirements perspective, I think that the unlink or garbage collect would be perfectly fine. So in other words, I would support that proposal. I think the only constraint to make clear in the text or examples or something, the part of the TEEP requirement comes from the case where you may have limited capacity and you're trying to, say, remove one component in order to free up space to do an install of a different component, where the first component is no longer needed. So great, I need to do the garbage collect before another install would succeed. And so if I understand what you're saying, because you say once the current section is complete, right? As long as you can order the sections such that the dependency graph is unaffected, then you could clean it up at the end of one section and install another one in another section. Is that correct?
Yeah, I think that you might be able to special case. Again, the big concern that I've got here is the atomicity, and having something fail after you've removed a component that's required for rollback is going to be a big problem.
Right. So my point is that in the TEEP case, there's two independent things that are happening, right? One is I no longer need component X. It's just an app. It's no longer needed for anything. In other words, it's a trusted app. So it's not an app that the normal user thinks of as an app, right? It's a binary that runs in the TEE that is not directly user visible. It's a library that's consumed by other applications that may not no longer exist, right? So you can clean up some space there. That's one thing. Separately, the authority over the TAM wants to install another app. Now, it could do those in two completely separate manifests and two completely separate protocol exchanges. And it's just trying to bundle them to do them at the same time, because there's a strict ordering if there's a resource requirement that says, I can't fit the second one in there. It's going to fail due to out of space unless the first one does. And so is there a way to bundle those two suit manifests into a strict ordering, but there's no dependency other than the ordering, right? The first one either succeeds or fails, and the second one can only succeed if the first one succeeds, right? That's what's the right way to express that. And I think you can do that by bundling the two suit manifests into a common manifest that just has an ordering in between them.
Yes, you can. I guess the question is, so this shouldn't be such a big problem, because the components that you're talking about should already have, before you start, no references. If you're deleting this thing, there shouldn't be any references to it, which means that the moment you get to I'm expressing I don't have any interest in this, and it's already got a zero dependency, then that should be a reasonably safe thing to remove directly.
Correct.
And I think that
the issues you're worried about are
text in that.
Yeah, I think the issues that you're worried about, and why I think that this solution I think is fine, come up in the non-TEEP cases, because suit is useful for other cases too, so you have to protect it. And that's why I think this is a better, the unlink or garbage collect semantic is better in general. I just want to make sure that it actually solves the TEEP case, and specifically when you start by having no references to it, and it is nice and efficient, but it's also safe to use outside of TEEP. And I think this proposal goes in that direction, but that was my question about what you meant by once the current section is complete.
Yeah, no, I actually did mean something different. So I mean, when the update process, the whole update process is fully complete, that's the time to actually do the garbage collection. But I think what we can have is a special case where there are no references to start with. So rather than starting at 1, which would be the standard situation for a dependency, you would start at 0. And since you're starting at 0, you know that this is not required, and that a failure later on in the process isn't going to render your system inoperable. Then it's safe to do a direct removal right away. I think that should be a reasonably safe approach.
Okay, so I see David Brown is in queue after me, but so let me just make one last comment, and then I will see if David has a response to this discussion. There's sorry, I just lost my train of thought. Yeah, there's two different ways that TEEP could accomplish this, between TEEP and suit, right? We could either say suit's going to do it, in which case you do what you just summarized. If we did not, if that caused problems for something, then the other workaround is that TEEP would pass two independent suit manifests in the same message and just run through the suit processing of those two manifests sequentially, right? And so that would be the workaround. If suit can't solve it, then TEEP could. It's just more work for TEEP, right? It's just which working group does it. So that's why I prefer what you just described, Brendan. But David, you let me know if you have other problems with that, because we have another possible approach we could take in TEEP. So I'll get out of queue.
All right, is my audio working?
Yes.
Perfect. I guess the question I would have is this reference count an ephemeral thing that is part of the update process, or is this a persistent piece of data associated with each image? If it were persistent, it would make sense that you would come in at the beginning of this process with a reference count already 0, and that would be known. Whereas, you know, say a previous update removed what depended upon it, and the garbage collect maybe could be implemented so that when it's asked to remove the item, if the reference count is 0, it could remove it then, otherwise later. But that does require storing this more persistently than just during an update.
Yeah, you're exactly right. So that's the intent. It would have to be something that's persistent. Now, again, I want to stress that this is only relevant when you have multiple non-interdependent routes. So that means you have essentially you have apps. If you don't have apps that you can install independently, then this is completely irrelevant. If you're dealing with system images that have dependencies, this doesn't become relevant. But when you have the ability to install individual applications, and those applications may have dependencies, then this reference counting thing starts to become a question.
Okay, that addresses, as long as we're clear about that, however we word it, I think is the important part.
Yeah, I think
Yeah.
that the version that's in there right now doesn't go into these nuances quite as well as I would like.
Yeah, just one other point of clarification. When we say apps, I would generalize that to the real case is really about like shared libraries, right? It just so happens that in TEEP, a trusted app is basically a shared library. But if you want to generalize it, the things with references are you can think of as just being shared libraries. Anytime that you have a multiple reference counts of dependencies on it, it's basically a shared library. So that's the case we're talking about.
Okay, hope you can hear me. Next slide. So for those who have been at the TEEP meeting yesterday, this is sort of an extended version of what I spoke about yesterday. So there are two. So I looked, as I mentioned, I looked at the MCU boot as a sort of as a real-world example on what is done today, and also spoke to David Brown, who was on the microphone previously, about what functionality is used and what they have implemented and how they did it and so on, and looked at that code. And there were two mechanisms, namely sort of a symmetric key based version of encryption, as well as, well, I should say, both of them use symmetric keys to encrypt the firmware because it's larger. But for the key exchange, there's the symmetric key version, which is the AES key wrap, and then there's the asymmetric key version, which uses elliptic curve Diffie-Hellman. And I'm going to walk you through how that looks like when embedded into the SUIT manifest. As a reminder, so I don't know how many of you remember what the COSI spec says among the different options, but those are two of them. And so I picked those because they map closer to what is being done already today in MCU boot. And I also looked at other bootloaders from NXP and ST Microelectronics, which use something very similar, obviously. So the encryption is typically used in two cases, as David Brown also confirmed to me. One is when you have a firmware image stored on an external flash, and then you use obviously the decryption operation to put it on the internal flash, because obviously you can only operate on the decrypted image to actually do an execute in place. The other option is when the encrypted image gets decrypted and then put into RAM for execution there. The former being more common. So in the IES128 key wrap case, I tried to summarize real quick. Russ is the lead also on that RFC. So in essence, there are two keys being used. One is the content encryption key, or CEC, which is used to encrypt, in our case, the firmware or software or whatever we want to encrypt with SUIT. And the other one is the key that is used to encrypt that content encryption key, which is also pronounced CEC, but it's the key encryption key. And the CA key, the content encryption key, is randomly generated, and then they externally provide key encryption keys then used to protect it. So that's a relatively simple technique, as you will see later. More complicated, though, is the public key based variant of it. Or yeah. So it's the COSI spec calls it elliptic curve Diffie-Hellman ephemeral static plus AES key wrap, and the procedure is roughly as follows. So the sender, sort of the firmware also in our case, generates an ephemeral elliptic curve Diffie-Hellman key pair, and then that sender then retrieves the receiver's static public key, which obviously it needs to possess, and uses the elliptic curve Diffie-Hellman operation on the using its private key, that the one that it just created in the previous step, with the static public key of the recipient of the IoT device, and generates this symmetric key, which I call it here ECDH shared. And then it needs to apply an HKDF function, which I will get into later because I think it's quite relevant to the types of profiling we are doing. And this produces the content encryption key and the key encryption key. And then the same procedure with key wrap is applied that I just explained. So the reason I'm pointing those out is because those are only two mechanisms out of the a range of different techniques that are made available with COSI, and I really think that we have to nail it down to a few of them and describe them precisely so that there is some level of interoperability, and also the code size is manageable. Next slide. So start off with the simpler one with this key wrap. So this is how it looks like as an example. I shortened the encrypted content encryption key here, but otherwise it's this should be a working example if I got it right. So this is a COSI encrypt, not a COSI encrypt 0. So I suggest to only use the encrypt version, which includes information about the key that is being used, which I think is quite useful. The yellow box is information used to encrypt the firmware, and so the first bucket here is sort of the protected field, which just encodes the algorithm being used here in our example IESG GCM128. The second bucket is an unprotected field, so-called unprotected field, or it's actually unprotected. Well, actually, the whole thing is protected, but leaving that aside, there's the IV in there, or the nonce that we use with the AAD cipher. And then we use only a detached ciphertext. So the firmware image is not included in here. So that's why there's a null as the last line in this yellow box. If we go to the blue box, this is the information needed for the key wrap. And it essentially says, here's the algorithm for key wrap. Here's the key identifier for that identifies the key encryption key that is used then to encrypt this randomly generated KEK, the content encryption key, which is the last line here. So this is then, and if I hope it's correct, but this is how then the example would look like, and with, of course, alongside with the encrypted firmware image. Okay, that's so there's one thing that needs to be
put in the queue. Do you want to take his question, or do you want to wait till the end of this?
Go ahead, David.
Are we there? Okay. Yeah, the question is actually in regards to, you mentioned the two use cases for this. I just wanted to point out, I remember a third one that hasn't gotten implemented in MCU boot, and there are microcontrollers that support loading a content encryption key into the hardware and are able to execute directly in place from an encrypted image. So I just wanted to point out that is, I know of real examples, they just didn't get upstreamed into the MCU boot code.
Yeah, that's true. There's some, it's a rarer case of microcontrollers. I forgot which one it is, but it's it basically has the hardware capabilities to do the decryption in hardware rather than doing something in software, which would require copy things around. You could also argue that another benefit of encryption is, which I didn't mention, is like you would additionally encrypt the binary all the way from the firmware also to the software that or to MCU boot, for example. Okay. Next slide. Yeah. So the AES key wrap needs an additional data structure, and this is encoded as shown on the screen, which the COSI spec defines. So there's the there's a string, then there's the protected field, and then some external additional data. And my suggestion is to have the external additional data defined as null, and my reading of the specification is that the protected field here, since we have two protected fields, refers to the outer protected field, so to the yellow box, not to the blue box I had shown on the previous slide. But I would need someone else to confirm that. That was my understanding of the spec, but in talking to Russ, I have misinterpreted the spec in other places, so I'm trying to be a little bit cautious here. So there's some clarification needed. I don't think this the null for the external AAD is controversial, so I will skip to the next slide. Okay, this is the more complicated technique, but security-wise better. So there's another, as you can immediately see, first of all, it didn't fit on one screen, but so there's a second one. But there's also another layer in here, in addition to the boxes I explained previously, which are slightly changed, but I will glance over those aspects. There's an innermost recipient box, which defines, essentially carries the ephemeral key that was created, obviously the public key, and it also includes a key ID, which refers to the key the sender, so the firmware author, expected what it selected from this static public key. And then otherwise, there's a lot of similarity here in terms of the structure. Okay, next slide. There's here for completeness, there's the ephemeral structure, which contains this public key. It's a cozy key structure, which also has a couple of options. And in the code I've been working, the Y component could be replaced by just a sign bit, but I include the Y component of the key because I couldn't figure out on how to get this to work with the embed DLS API. But I'm going to look into that. So, but I would suggest to have one specific encoding rather than the choices that are being offered, because you can have compressed points and of course, there's also the question about what curves and what algorithms should be recommended in the SUIT specification, because there are obviously also a lot of choices. Next slide. I didn't go into the algorithm recommendation here, actually. So this is the complicated part, which I think is really important to also specify in the document, is because here in the gray box, you see how the procedure works to generate this key encryption key. It's basically using an HKDF applied to the ECDH shared key with some context. And the context is rather complicated. It's this cozy structure, which needs to be populated with different parameters. And there's the identities of the two parties, and I assume U and V in our case refer to U would be the firmware author, or the party that generates the encryption, and V is the recipient. So in our case, the IoT device, and so the key ID would be a good fit for the recipient, because that's something we already include, as I mentioned previously, for selecting the right key on the IoT device for the elliptic curve Diffie-Hellman. But for the sender, I wasn't quite sure what identifier to include here. So that's something that needs to be worked out. There are also nonces in all of those party infrastructures, which I would suggest to use nil or null here, because I didn't really know I couldn't figure out what nonces we could use here. We could probably carry some additional nonces in the payload, but I wasn't sure on what added value those would provide. So maybe someone has some ideas and has different use cases that would justify this. And then there's also the it's called sub-pub info, which contains the protected parameter and the algorithm ID, the date, and the key length. And again, here the challenge is like ideally what parameters would be used here? Would we use the algorithms that are used to encrypt the CAC, or would we use the so essentially the information from the yellow box or from the blue box, which at least from my reading of the spec of the COSI spec, at least wasn't clear to me. And then there's some other and some additional information which I would have also suggested to use null here, or to not populate unless there's a good reason. But maybe someone of you has an idea. Russ, David.
So the reason for the nonce is if the ephemeral key is going to get used more than once, it is to make sure you compute a different key for the KEK. If you're sure, 100% guaranteed positive that it will be used for one and only one firmware image, then you can avoid the nonce.
Okay, so in that, so ideally, like for the scheme, since the sender's ephemeral key pair, it was supposed to be ephemeral, as the name says. They are probably, you wouldn't want to include a nonce. But what about the static key of the recipient, which clearly, as the name suggests, is static? Would that require me to use a nonce?
No, as long as one of the keys is truly ephemeral, single use, you can get away without the nonce.
Okay. So what would you recommend in terms of like specification? Because ideally, like this is, I would like to leave as little options as possible because it makes this implementation simpler. Would you always carry a nonce around?
You say the ephemeral key is only used to encrypt one content, then you can get to that position, or you could do the belts and suspenders approach and say, you know, the source must include a nonce. Go ahead, David.
For you to respond. Did we lose you?
Yeah. Yes, I just wanted to add, as far as the nonce goes, we have patches coming into MCU boot to implement the nonce, but within MCU boot, despite the all of our uses do only use this to encrypt one image ever. One of the users basically decided through their security analysis that the encryption had not been studied without the use of a nonce, and they felt more comfortable having it in there. So within a few weeks, probably MCU boot itself will support a nonce. It still works without it being present in the manifest, but it does allow it. So I don't know if we want to allow that in the spec or not.
I actually have a question about that. It seems like if we do this in the manifest document, that this is going to push the time that we publish the document out, quite a bit. And just an observation, we tend to have a pattern of, getting the manifest document fairly close to done and then adding features to it. And that has been kind of extending, the time that we're working on it. I'm interested in thoughts on how we might be able to, split this work in a way that would allow us to move forward with the manifest, but still address, this problem space. Any ideas on that? Go ahead, Brendan.
is essentially the same as what I'm recommending with the examples at the moment. Not necessarily that we take the examples that are in there and split them out, but that any additional ones could get adopted into a new examples document. I think here we might want to also consider the possibility of defining a set of profiles and having those profile definitions live in a separate document as well. I think that we could make a pretty sound argument for saying, this is a minimum device and these are the features it has, and this is the minimum device with encryption and these are the things you have to implement. So I think that we could probably make an argument for defining profile documents, informational ones, as separate from the primary draft.
Any concerns with that approach? Oh yeah, sorry, Russ.
Profiles are inevitable, I think, when we have algorithm choices. So I think it'll be interesting when we get to what are the mandatory to implements, because that's what'll get us, a base spec. But profiles that address different communities are going to happen. So let's just be realistic and set that up. But the features that are being discussed here are already in the spec. We're just talking about how to use them with the profile, with the algorithms that Hannah started the presentation with.
Yeah.
We're down to 9 minutes left in this meeting.
We are. Dave Thaler and I were talking briefly about that. Given that this is one of our significant work items, it's probably worth spending the time to move this forward. As far as I just had one question, and we can move on. As far as the MTIs, is that something that we want to do in a separate draft to be able to support algorithm agility without having to revise the base spec? Any thoughts? Go ahead, Hannes.
Can you hear me again?
Yeah.
Oh, sorry, I lost internet connectivity. Okay. Did you move on in the meanwhile?
No, we were just having a discussion about, how we maybe split some of this work in a way that would allow us to move forward with the base spec while you were gone.
Okay.
Yeah. Other security protocols have put algorithms in a separate doc, just so that if the base protocol were to advance to internet standard, then the algorithms could still be changed without pulling the base spec down the ladder.
Yeah.
Right.
That makes sense. Yeah. Yeah. And would you include algorithms like the key exchange algorithms, or are you talking mostly about let's say AES GCM versus CCM or so?
I think that's to be worked out.
Okay. Because I think without detailing these parameter configurations on the left-hand side, or the right-hand side, these bullet list, I fear that there would be, with no guidance, chances that two implementations are interoperable are close to zero.
Right, and I guess the question that I raised, Hannes, was, doing this work is going to add time, more time to our schedule, for getting this published, and I was looking for ways to, to move the base spec forward while we work on some of these things.
Yeah, maybe one possibility is to just have the very basic functionality in there, like the AES key wrap that I presented at the beginning, and to have the sort of more sophisticated version then covered separately. If you, for example, if you advance to the next slide, there was also a question. Or maybe even the one further. This one. So I noticed that like there are obviously many different public key, elliptic curve public key encryption schemes, and selecting one of them is tricky. But luckily there's also work. So clearly there are a number of choices given by the COSI spec, but then there's also some more recent work done in the CFRG on the HBKA, which is this hybrid public key encryption scheme. And maybe that's also a sort of, or at least I thought it would be useful to look into this, because this is currently being sort of incorporated into the TLS 1.3 client Hello encryption, and also MLS uses it. So maybe there's a possibility here for reuse as well. And then also the case of multiple recipients, which the mechanisms I explained earlier are supported by those two. That's also something to consider.
Yeah, so just trying to get to the end of this discussion for today, because we've only got about 4 minutes left. And so I guess what I'm hearing so far is proposals to put the encrypted the use of SUIT for encrypted binaries and things, the details all into a separate document. And if we do that, then I guess my preference would be to put as much of the discussion about that as possible into a separate document, and just make sure that the base spec includes it is easy to extend in another document, and say, such and such is left for a future document, and that's fine as long as it does not have to update but only extend the base spec. Then that seems to be a good decoupling, rather than saying putting some part of it in the base spec and some part of it in a separate document. If we split it, I prefer to really put everything about encrypted manifests or encrypted binaries and things into a separate spec that includes examples. If there's any new commands, I don't know if there's any, I've not heard any yet, but all the algorithm stuff and so on. And if we do that, because Roman is asking, what is the new milestones we would set? Because I think that type of approach would allow us to have a earlier milestone for the earlier date for the base spec, because it's pushing more of the stuff into the other spec, which would have a later milestone. And so that would be my preference. And I'm looking at the other chairs to see if David or Russ, you have a preference. I'm just trying to get a particular recommendation so that we can decide when we say charter milestone updates and stuff, how we do that. So.
Yeah, and I think
that works for me, but I think we'll have to have an interim meeting to make that happen.
Yeah, I agree. I was going to suggest something similar. Yeah, and we'll have to factor this into our charter update, definitely.
So with only 2 minutes left, I wonder if Brendan, you want to even start one of these other presentations, or we should just push that to the interim.
Oh, I can talk fast, but I don't think I can talk that fast. And
I guess
even if I could, I'm not sure anyone would get anything out of it.
Is there anything you want to point people to in the time remaining?
I'm not sure. I think the big question for me is following on from the previous discussion here. Do you think that it makes sense to factor out all of the examples that currently live in the manifest document, or simply say that additional examples may show up as time permits? Essentially what I'm saying here is, does it make sense to provide some examples so that implementers know how this fits together without necessarily having every possible example? Or should we move all examples out to a new document? So
I think
some
that's a
examples
good
to a new
question to
document,
take
or
to the
all
list.
examples to a new document. Yeah. Okay.
Yeah, I think we're going to have to discuss that on the list, but there's clearly advantages to implementers to have them. So,
Okay.
But early adopters can implement from internet drafts. We know that.
So I don't think we've got enough time to cover anything else. So I think we should probably leave it there.
So should we shoot for maybe the end of April for an interim?
I
Are
think
there any
that's right.
major dates that we should avoid?
We'll have to do a doodle, right?
Yeah. All right, we'll do that then. So I guess with that, we're out of time. Sorry, Brendan, we weren't able to get to the other topics, but we wanted to make sure we were making progress on the base spec here. Thanks for presenting. And with that, I think we're going to wrap things up. We have a few discussions that we're going to take to the list. There's some rechartering work that needs to be done, which we'll also take to the list. I guess with that, thank you, and we'll talk to you soon at hopefully at the virtual interim. Thanks again.
And thank you to the note takers.
Indeed.